All right, 29, for what value of t is there no ordered triple ABC that satisfies all three equations shown? All right, well, I'm just going to try something out right now. I want to try out what happens if I just add these all together. So a plus 2a. Well, I'm going to write that out. A plus 2a. I'm sorry, that's not 2a, is it? That's TA. TA. And you know, I hate using t's whenever there's a plus sign, so I'm going to use capital T. So TA like that. There we go. So now another way to write this, a plus TA, is what do they all have in common? They're GCF. There's always an A, isn't there, in those three terms. So I can pull out an A, right? So A goes into A one time, A goes into A one time, so A, 1 plus 1, plus, and then A goes into TA, T times, so plus T. So really I'm pulling out a 2 plus T is what I just pulled out, because 1 plus 1 is 2. So I'm going to rewrite this now. So when I add this up, I get A, and then 2 plus T is in parentheses. When I add these up, the same thing happens with the B's, right? So it's going to be pull out a B, and then 2 plus T. Same thing happens with the C's. So pull out a C, and then 2 plus T again. But then it's going to equal 3T. Well, something interesting happens if I set what is in parentheses here. If I set that equal to 0, watch what happens. 2 plus T equals 0. I would subtract 2, and T would be negative 2. Now, what happens if T is negative 2? Well, that makes this thing 0, and 0 times A would be 0, plus 0, plus 0, and so that would be 0, but we said T was negative 2, so 3 times negative 2 would give us negative 6. Well, those aren't the same. So that does not satisfy all three equations. So that's going to be the instances. If you set that thing equal to 0, you're going to get T is negative 2, and that's when it doesn't work, because 0 cannot equal negative 6. All right. So we used a little GCF on that one. Okay, our next one is pretty interesting. So this one says, how many positive divisors does 5 to the 12th minus 2 to the 12th have? Well, those are stinking huge numbers, right? And we don't have a calculator, so we're going to have to figure out an easier way to do this. Now, this is set up in difference of squares. So difference of squares means, if you'll recall, a squared minus b squared is the same thing as a plus b, a minus b. This is difference of squares. So in other words, I could factor that out and say 5 to the 6th plus 2 to the 6th and 5 to the 6th minus 2 to the 6th. And then the reason that works is this times this, you keep the base the same and add the exponents, and 6 plus 6 is 12, which matches that one, right? So that's how that works. And then this one's broken down as far as it can go, but this is another special case there with the difference of squares. So I can make that one become 5 to the 3rd plus 2 to the 3rd, 5 to the 3rd minus 2 to the 3rd. Okay? So now I'm getting somewhere. And there's a cool little trick with the 5. So check this out. For 5 to the 6th, I need to find that value. What's the same thing as 5 to the 3rd times 5 to the 3rd, isn't it? And that's 125 times 125. Now, anytime you multiply with a number ending in 5, if you're squaring it, which is what we're doing here, 125 squared, or 125 times 125, I can just take this number and multiply it by one more than that. So 13, 12 times 13 is 144, 156. And it always ends in a 25 when you square a number ending in 5. It always ends in a 25. So 125 times 125, I just think of it as 12 times 13, and it ends in a 25. So it's 15625. And then 2 to the 6th is the same thing as 2 to the 3rd, which I know is 8, times 2 to the 3rd. So 8 times 8 is 64. So just add 64 to that. And that one is done after I do that. So now I can start erasing that and replacing it with my new number. So that's 15689 for that one. And then I'm going to do the same thing for the other one, but this one's 15625. This one says minus 2 to the 6th. Oh, but I guess I rewrote that one, didn't I? So I don't even need to do anything with that one because I rewrote it to be this and this. So that's going to be 125 plus 8, so 133. So I'm going to rewrite this one to be 133. And then this one is 125 minus 8, which is going to be what, 117? So I'm going to rewrite that one to be 117. And now, hopefully, we can figure out some other factors here. So in other words, this one, if I break it down with its factors, that's a multiple of 9. So 9 times 12 is 108, so that's 9 times 13. And then break that one down, that's 3 times 3. And then break this one down, so 133, what else goes into that? I think 7 goes into that, because 7 times 20 is 140. Take away a 7, so that means 7 times 19 is 133. Those are both prime. 15, 6, 8, 9. Oh man, I'm going to try to use my divisibility rule, see if I can find something that goes into that. And it's not a sum of that's a multiple of 3 or 9, so that doesn't work. It's not an even number, so we're going to need to start trying some prime numbers, right? So we're going to try 11 and try 13 and try 17 and 19. And when we tried 29, it works. So we get 29 goes into that 541 times. And then I'm just going to keep rewriting these numbers so in their prime factored form. So 7 and 19, so I'll erase those now. And then I have 2 of the 3, so that's 3 squared times 13. Now there's this really